Hey everyone, this is Professor Kemp. This is the third video in the software development process series that I've created. The first video that we created went through the analysis phase. There's two steps that I use in the Modified Waterfall process that I use to actually get me to the end of the analysis phase, and that is step number 1, understand the problem, and step number 2, envision the objects. And that's what we covered in the first video. In the second video, we covered the first part of the design phase of the software development process, and we did the non-graphical representation of the pseudocode. So what we're going to do now is we're going to go into the graphical representation of this pseudocode. And for that, let's go back and let's take a look at where we are and what we've done so far. So we've got our problem statements, and our problem statement was again from the book. This is problem number 2. We've been asked to write a program that takes the length of an edge as an integer as input and then print the cube's surface area as output. So that's our problem statement. Step number 1 is identifying our output. We identified that we have one output, and that is the surface area. So next I created what is known as my IPO chart, the input process output chart. We identified our output as the surface area. We identified that the user was going to input the data that we were going to need to do the mathematical computation to create that output. So the user is going to input the edge. We're then going to calculate the surface area by taking that edge times itself times 6 to get the surface area of that cube. So next we went into what is known as the design phase, and we built the non-graphical representation of this algorithm, and that was with pseudocode. For pseudocode, we don't use actual syntax of any programming language. We're going to use some simple words, and I always use get, set, puts for each of these phases of the IPO charts. I'm always going to use a get for inputs, set for process, and put for output. So as we can see here, our algorithm is the logical series of steps the computer must take to complete the output, or to complete the task. Where our output, or our task, is to compute and output the surface area. Well, I can't output this surface area until I compute the surface area. Well, I can't compute the surface area until I get the edge. So my algorithm is simply get the inputs, calculate the surface area, output the display, using simple keywords such as get, set, and puts. I'm going to get the variable edge. I'm going to set the variable surface area to equal the value of what the user inputs as the edge times itself times 6, which will represent the value that is calculated in the surface area. Then I can simply output the surface area. So that is the non-graphical representation of this algorithm. Next, we're going to build the graphical representation, and that is done in what is known as a flowchart. And I use an application called Raptor. And Raptor is a program that allows us to create flowcharts. And a flowchart has symbols. The symbols represent the phases or the things that we're going to do on our algorithm. So you'll notice that we have inputs, we have outputs. So this is going to be our gets, this is going to be our sets, this is going to be our puts. So we've got gets, puts, and then we have our assignment, which is the symbol, which is the straight up square. So we've got a parallelogram with an arrow going in to represent inputs. We've got a parallelogram with an arrow pointing out for output, and then we have a straight up square for the assignment. So again, I'm going to use the non-graphical representation of the algorithm, and I'm going to use an inputs for gets. I'm going to use a straight up assignment for sets, and I'm going to use an outputs for puts. And this is the graphical representation of the algorithm. Now, the benefit of using Raptor is simply allowing us to take these symbols and make them executable. Now, before we do that, one of the things that we have to do is that we have to internal documentation. Since I've already created this internal documentation over here, I am just going to go ahead and I am going to copy and paste it over here. So, the start of my program is the comments, the name it, date it, claim it comment that I call. And we're going to request the user inputs with this symbol right here. And I'll move this over here to get it out of the way. And then I'm going to calculate the surface area with this symbol right here. And then I'm going to output or display the surface area with this symbol right here. So that's what each of those symbols represents. Request the inputs, calculate the surface area, output the surface area. Now the next thing I'm going to do is I'm going to make this executable. To make it executable, I am going to click on Edit, and this here is going to be enter the prompt here. This is the prompt that we want to prompt the user with to tell him exactly what we want him or her to put in the variable. And we said we were going to tell them to enter the cube's edge. And rules of syntax for Raptor are, anytime we're doing a prompt, a series of strings that we want to output, we're going to put them in quotes. And this box down here is going to represent the name of the variable that we want to store this data in, which we said was going to be edge. And Raptor is going to tell me to go ahead and save now. So I'm going to go up to my desktop. I'm going to find my program folder, and then I'm going to name it cube.flc to represent that it is the external documentation for the flowchart for this program. And as you can see, now that I've saved it, I have the enter the cube's edge as a part of that input parallelogram. Next, I'm going to calculate the surface area. So this is the set. Notice the little set right here as well. It kind of matches up to the set right here. And this here in the set is the name of the variable that we want to store the value of the mathematical computation. And we said we were going to put that in surface area. And the mathematical computation is going to take the edge times the edge times 6. And so that's how we calculate the surface area. And then next what we're going to do is we're going to output the surface area. And I'm going to give it a little label that says the surface area is concatenation. I'm going to string together the value of the variable surface area. And that would be the graphical representation of this algorithm. I'm going to get the edge, I'm going to calculate the surface area, I'm then going to display the surface area, just exactly like I said in my non-graphical representation. Now, the other great thing about Raptor is that it is executable. So I can actually run this program and get an output for the surface area of a cube. So I can now run this program and say if my cube's edge is 6, it's going to take 6 times 6 times 6, which is then going to be 216. I can see here in my process window that it's going to produce 216. And then the great thing about Raptor is it gives us this little master console that says the surface area is 216, which represents this output symbol right here. Surface area equal 216. Now, how do I know that that is actually correct? And that's going to move us into the next phase of the software development process, which is a part of the testing.